Let's start with switches. A mechanical switch is a device that can open or close, thereby allowing a current to flow or not. As you have no doubt observed, switches come in many different shapes, sizes, and configurations. Probably the most common switch type is the toggle switch, which is available in various contact configurations. Each switch consists of one or more poles, where each pole is actually a separate switch. The contact arrangement for the single pole, single throw switch, or SPST, the simplest switch, is illustrated in Figure A. Notice that it has a single set of contacts and that can either open or close. Next, up the line of complication, is the single pole double throw switch, SPDT, illustrated in Figure B. Notice that the movable arm, called the common, marked C, or wiper, can connect with either contact A or contact B. Figure C illustrates the double pole double throw switch, DPDT, which consists of two electrically separate SPDT switches, single pole double throw, in one housing that operate together. In Figure D, notice how the terminals are arranged on the back of the DPDT switch housing, with the three terminals for each pole running the long way of the switch body. Although not as common, switches with up to 6 poles are available. So far the discussion has centered on the two-position switch, which comes in two configurations, the simple on-off and the on-on. A three-position switch, called an on-off-on, has a stable position in the middle, where the C contact is not connected to either A or B. Such a switch could be used to control a motor, where the three positions would correspond to forward, off, and reverse. Another variation of the toggle switch is to have one or more of the positions be spring actuated, meaning that physical pressure must be maintained on the handle to keep it in position. These are called momentary contact switches, an example of which is a car's ignition switch, where you must maintain continuous pressure on the key to engage the starter motor. Toggle switch contacts have maximum voltage and current ratings of AC and DC operation. A typical toggle switch can handle less DC voltage than AC voltage at the rated current. For example, a switch might be rated at 5 amps for 125 volt AC or 5 volts for 28 volt DC. The reason for the difference is that when the contacts are just opening, the current will continue briefly to arc across, which tends to burn and pit the contact surface. AC will arc less than DC for the same voltage because AC is going to zero twice each cycle. Also, most toggle switches have a snap action which pulls the contact apart rapidly to minimize arcing. Closely related to the toggle switch is the slide switch. Although mechanically different internally, the slide switch performs the same function as the toggle switch and is available in the same configurations. Slide switches tend to be less expensive but are not available with high current ratings of the toggle switches. Push-button switches are almost always the momentary type. Pressure must be maintained to keep the switch activated. Figures B to D show the symbol for the push-button switch. Notice there are two configurations possible, normally open and normally closed. For the normally open switch, Figure B, the contacts are open until the button is pushed. And for the normally closed switch, Figure C, the contacts are closed when the switch is at rest and open when the button is pushed. A limit switch is a push-button switch mounted in such a position that it is activated by a physical contact with some movable object. An example is a car door switch, which senses whether or not the door is closed. Limit switches are available with different kinds of actuator hardware, such as the paddle or roller. Often, these are mounted on a small, standard-sized switch body called a microswitch, developed by the Microswitch company. A microswitch requires very small throw of a few thousandths of an inch. Limit switches and other proximity sensors are discussed in Chapter 6. A dip switch is a set of small SPST, single pole, single throw switches built into a unit shaped like an IC circuit. DIP stands for dual inline package. The dip switch can be plugged into an IC socket or soldered into a circuit board. As shown, each individual switch uses 2 pins directly across from each other. That is, switch 1 uses pins 1 and 14. Switch 2 uses pins 2 and 13, and so on. Do not use a pencil to set the switches. The graphite can work its way into the switch and short it out. A rotary switch is a considerably different type of switch from the ones discussed so far, and can perform multiple complicated switching operations. As shown, the rotary switch is constructed of switch wafers mounted along a single shaft. The inner part of each wafer rotates in step with the shaft, and the outer part remains stationary. To understand how the switch works, consider Figure A, which shows the switch in the off position. In this position, the C terminal, the common terminal, is making contact with the pad, but the pad is not touching terminals 1 or 2. In Figure B, the shaft has been rotated clockwise to position X. Notice that the common terminal is still connected to the pad, but now the little extension of the pad is making contact with terminal 1. In Figure C, the shaft schematic has been rotated to position Y, and now the pad is in contact with terminal 2. Notice that there could be 3 or 4 such switches on the same wafer, as well as multiple wafers. A thumb wheel switch, a special type of rotary switch, is used to input numeric data. The operator selects a number by rotating the numbered wheel, and each number corresponds to a different switch setting. The switch schematic in Figure B shows that one of 10 separate terminals is connected with the common terminal. Also available are thumb wheel switches that output 4-bit binary coded decimal, BCD, and other codes. You can Google BCD or just know that it is a format used for converting 4 bits of binary to represent a digital number, which is useful when driving base 10 digital displays. Another type of data input device is the membrane switch keypad. This type of keypad consists of push-button switches built up from a number of layers, as shown in Figure A. The bottom layer is usually a printed circuit board with 2 connecting pads for each switch. Lying over the circuit board is a spacer layer with a hole for each switch position. The third layer is flexible and has a conductive pad over each switch. Overlying the whole thing is a flexible waterproof membrane which has the key lettering. When a key is pressed, the conductive pad is forced into contact with the circuit board and provides a path for the current, as illustrated in Figure B. Membrane switches are especially appropriate in dirty industrial environments because the membrane keeps dirt from getting into the switch assembly. That ends our section on switches.